Transmission across a synapse. How is information transmitted across a synapse? Just a bit of a recap of the structure of a synapse. You've got the synaptic knob. This is the presynaptic membrane. You've got vesicles with neurotransmitters. There's a synaptic cleft. There are receptors on the postsynaptic membrane, and this will be either another neuron or an effector muscle or gland. So the effect of an action potential. When an action potential reaches the end of a neuron, it causes neurotransmitters to be released into the synaptic cleft. They diffuse across the postsynaptic membrane and bind to receptors. When the neurotransmitters bind to receptors, they might trigger an action potential, cause muscle contraction, or cause a hormone to be secreted. Because receptors are only on the postsynaptic membranes, synapses make sure impulses are unidirectional. They only travel in one direction, from the presynaptic to the postsynaptic. Neurotransmitters are removed from the cleft, so the response doesn't keep happening. So they're taken back into the presynaptic neuron or broken down by enzymes. So there's many different types of neurotransmitters. Acetylcholine, which binds to cholinergic receptors, is quite a common example. Synapses that use acetylcholine are called cholinergic synapses. So the sequence of events that happens at a cholinergic synapse. This could be a 6-mark question in an exam. So the first thing is that the action potential arrives at the end of the presynaptic knob of the presynaptic neuron. This stimulates voltage-gated calcium channels to open, and therefore calcium diffuses in to the synaptic knob. Then that causes, the influx of calcium causes the synaptic knob to move the vesicles towards the presynaptic membrane, and the vesicles then fuse with the presynaptic membrane, releasing the neurotransmitter acetylcholine into the synaptic cleft by exocytosis. Then the acetylcholine diffuses across the synaptic cleft and binds to specific cholinergic receptors on the postsynaptic membrane. And this causes sodium channels in the postsynaptic neuron to open, and the influx of sodium ions causes an action potential on the postsynaptic membrane. Acetylcholine is removed from the synaptic cleft, so the response doesn't keep happening. It's broken down by an enzyme called acetylcholinesterase, and the products are reabsorbed into the presynaptic neuron and used to make more acetylcholine. So, sequence of events. The action potential arrives at the end of the presynaptic knob. This causes calcium channels to open and calcium flows in. That causes the vesicles with the neurotransmitter to move towards the presynaptic membrane and release the neurotransmitter acetylcholine into the synaptic cleft. The neurotransmitters then move across the synaptic cleft and bind to specific cholinergic receptors on the postsynaptic membrane. This causes sodium channels to open, and therefore sodium flows in to the axon, producing an action potential in the postsynaptic neuron. Then what happens is, so that the action doesn't keep happening, acetylcholinesterase breaks down the acetylcholine back into its two products, so the choline and the ethanoic acid. They're reabsorbed back into the presynaptic membrane so that acetylcholine can be made again. So, this is very similar to what happens at the neuromuscular junction, but there are a few differences. So there are specialised cholinergic synapses between a motor neuron and a muscle cell. The neuromuscular junctions use the neurotransmitter acetylcholine, which binds to cholinergic receptors called nicotinic cholinergic receptors. Neuromuscular junctions work like cholinergic synapses, but there are a few differences. The first one is that the postsynaptic membrane has lots of folds that form clefts. These clefts store acetylcholinesterase. The postsynaptic membrane has more receptors than other synapses as well. And when a motor neuron fires an action potential, it always triggers a response in a muscle cell.